So welcome to this new video. So on the screen we can see one question which came in IIT 2020, and it is asked to find the magnetic moment of this loop. That loop is given in the diagram, and we all know how to find the magnetic moment, and that is very simple. But this diagram is not that much simple. But you can see this diagram is a combination of two simple diagram or two simple loop. So how to find the magnetic moment in this case, that we will learn from this video. And those who came to solve this question, I will request those students to pause this video here and try to solve this question on your own. During solving, if you have any doubt, then you can run this video. After solving this question, lots of concept of magnetic moment and vector will be clear. So let's start solving this question. So before solving this question, we have to know what is magnetic moment and how to find the magnetic moment of a given current carrying loop. So in this diagram, so here you can see one loop, one circular current carrying loop, and there is a current flowing, and there is a current I is flowing through it, or the area of the loop is A. So I is the current flowing through it, and the area of the loop is A. Then we all know that magnetic moment, which is denoted by M, is given by I into A. That all we know. So this is the magnitude of the magnetic moment. We all know that this magnetic moment is a vector quantity, and the direction of the magnetic moment is given by this equation I a vector. So it can be seen from here that the direction of the magnetic moment is same as the area vector. Now we all know that this magnetic dipole or this current carrying loop behave as a magnetic dipole, and one side will be north and one side will be south. North will be in the same direction, in the direction of the magnetic moment, and the opposite side will be south. And this is similar to a bar magnet or a magnetic dipole. So this current carrying loop is equivalent to a bar magnet or a magnetic dipole. And this side is north pole and this side is south pole. This magnetic moment vector has the same direction of this area vector. How to represent the direction of a vector, that all we know by its unit vector. So if you want to represent the direction of any vector, you have to mention its unit vector. So by unit vector you have to represent the direction of any vector. So in this case, if you want to find the direction of the magnetic moment vector M, and we know that magnetic moment vector M and this area vector both are in the same direction, so finding the unit area vector will give the direction of the magnetic moment. And so this m is equal to I into A. This is the magnitude of the magnetic moment, and this equation or this is the unit vector of the area vector, that is same as the direction of the magnetic moment vector. One thing you have to know that this loop is a circular loop, but this formula is applicable to any loop which is plane. This loop can be a rectangular loop, this loop can be a circular loop, this loop can be a square loop, whatever it is. If this loop is a plane loop and there is a current I, this formula you can apply. So magnitude of the magnetic moment is I into A, and as the direction of the magnetic moment and area vector both are in the same direction, so the unit vector of the area vector will also give the direction of the magnetic moment. So how to find the area vector? That is also very simple. If you curl all your right hand fingers towards the current, then thumb will give you the direction of the magnetic moment. In this case, if you apply the same rule, you will find that this is the direction of the magnetic moment, or this is the direction of the area vector. A vector. This is the direction of the A vector. Okay, as this magnetic moment M has the same direction of the area vector, so we have drawn this magnetic moment vector in the same direction of A. These concepts are very important. So you have to use this concept to solve the question what was given on the screen. So let's solve that question on the basis of this concept. So in the diagram we can see that two individual surface or two individual loops are there. One is A, B, C, D, and another one is D, E, F, A. So these two are individual simple surface or plane surface. If one single such loop is given to you and you are asked to find the magnetic moments, that would be very much simple. You have to just apply that formula I into A and you will have the magnetic moment. But this loop you can see that is a combination of two such loop or two simple loop. So what you have to do here, first you have to find the area vector of the first loop ABCD. Then you have to find the area vector of ADEF. Then you have to find the resultant area vectors of those two vectors. And that resultant area vector is the representation of the area vector of the whole loop. Now if you multiply the current with the resultant area, then you will get the magnetic moment. So that is the way you have to solve this question. Now you can use this idea to solve this question on your own, or you can see the solution here. Now let's start solving this question. If you consider this first loop A, B, C, D, it has an area is equal to A into B because A is the length and B is the breadth. So the area is A into B, but area is a vector quantity. Then what is the direction of the area? From the right hand thumb rule, you can see the direction of the area vector will be in this direction, in the Z direction. And if we denote this area by AZ, then it can be written as A, B, K cap. And for this loop A, D, E, F, for this loop, this is the individual area. And this area is also same AB, but the area vector or the direction of this area is not same. And from this right hand thumb rule, you can also see that the direction of this area vector in this direction, that is in the direction of the J cap or in the positive Y direction. And if we denote this area by AY vector, then AY can be written as AB J cap. Then what is the net area vector of this whole loop? That is the vector summation of these two area vector. So you can represent this thing A vector is equal to, that is the net area vector of this loop. So A vector is equal to AY plus AZ. So what is AY? AY is equal to AB J cap and AZ is equal to AB K cap. Take AB common, so this become J cap plus K cap. So now these two vector, one is AZ and one is AY, you can represent by these two vector like that. Take this as AY and take this as AZ. Both length should be equal, but there is no space to draw, that's why one length is short and one length is bigger. So that is not the problem. The thing is that the resultant of these two vector will give you the resultant area vector of this whole loop. So that is in this direction. So this is A. This vector is A vector. So we have found what is the A vector. Now what is the magnitude of A vector? Magnitude of A vector that you can find, both AY and AZ both are perpendicular. So you can directly use the Pythagoras formula to find out the resultant. What is the magnitude of the resultant? Then it comes out that root 2 AB. Now what is the unit vector? We have to find the unit vector here because Why? We have already discussed. The unit vector A is equal to, and we all know how to find the unit vector. Any vector, if you divide that vector by its magnitude, that will give you the unit vector of that vector. So here the A vector is given by this one, and the magnitude is root 2 AB. So if you divide this by this, then you will get the unit vector of A, and it comes out that J cap by root 2 plus K cap by root 2. So that is the unit vector. So then what is the magnitude? Then what is the magnitude of magnetic moment? M is equal to I into A. And how much is the I? That is also given in this loop. This capital I is the current. And how much is the A? The net area of this loop, that is root 2 AB. So I root 2 AB is the magnetic moment. And as we know that magnetic moment vector has the same direction as the area vector, so the unit area vector also represent the direction of the magnetic moment. So the answer will be M along this vector. So hope you understood this video. Now let us find which option is correct. So this option you can see that root 2 AB I and along J by root 2 and K by root 2. So this option is correct. So hope you understood the concept behind this numerical. If you find this video is helpful to you, please like this video, and if you want more video like this, you can subscribe to our channel to stay in this channel, and see you in the next video. Thank you.